Well, I think we should slowly start. So some people still might join us, but welcome to everybody to this webinar series of the MIST project with the title Future of Air Cleaning Technologies. So we'll have two presenters today, which I will introduce later on. But first, let me introduce myself. My name is Marcel Lomans. I will be the moderator. So I'm working as an associate professor here in Eindhoven University of Technology in the field of indoor environmental quality and the performance of it. So I have a long experience in looking into this performance of the indoor environmental quality, focusing mostly on thermal comfort and air quality, and also very much interested in the actual outcomes. If you look, for example, learning performance, sleep quality, but also reduced infection risk. And this last couple of years, my attention with my colleagues here in Eindhoven, but also with other institutes, together with other institutes in the Netherlands and abroad, has been much on the ventilation and air cleaning in relation to the exposure to viruses, of course, with COVID in mind. And it is in that context that I'm very honored to host this webinar as part of the MIST project. And also thank you to Adse Boerstra and Elham Maksudi Nia for organizing this event today. Well, about the MIST project. So maybe you don't know or haven't heard about this project. So it's a large project running in the Netherlands, and it aims to develop mitigation strategies for controlling the airborne infections and then looking into HVAC technology, so ventilation and cleaning. And also trying to come up with solutions and protocols how to deal with this best. MIST is a really large project. It has many participating institutes working on it. It also is divided in a number of work packages. And you see them shortly mentioned here. So we have the work package 1 with a focus on the airborne pathogens and especially the effectivity. So it's more related to the medical issues. When we're talking about infection risk, here we have work done by the Groningen University Medical Center. They will look into the epidemiology, virology, so how's the infection risk actually if you have viruses in droplets, and they will look into that, also face masks, for example. Then we have work package 2, which is about the spread of airborne droplets. This is a more fundamental project where Twente University is leading, and they were looking into how the droplets develop, what's the effect of temperature, relative humidity on the droplet lifetime and so on, effect of turbulence. That's all what's being dealt with within that work package. Work package 3 focuses on the ventilation and the ventilation concepts for removal of airborne droplets, but also using air cleaning technology for that. And we're trying to come up with solutions at room level, but also with local solutions to deal with more local exposure. And I say we, because in this case, Eindhoven University of Technology is the work package leader. Then we have work package 4, which is led by the University of Amsterdam, which deals with use cases and tries to look into actual situations and see how they can be addressed when we want to avoid infection risk or exposure risk to contaminants. And so we have examples in more real life situations that are being investigated within that work package. And then work package 5 combines more or less all the information that we try to obtain from the other 4 work packages to come up with strategies for infection control. And this is led by TU Delft, by Adse Boerstra. And also it's very important, an important part of this work package is the dissemination of results to the public. And in this case, the webinar is one of the outcomes of this work package. I've mentioned several institutes already which are working in this MIST project, but we have many more who are involved in the project. Here you see an overview. So a lot of academic institutes, which is really nice. That is very multidisciplinary. So it's very important to look at these types of problems from a multidisciplinary perspective. But we also are very glad that we have lots of industrial partners and societal partners which can help us understand the problem better from their perspectives, and also support us in several ways to reaching the goals that we aimed at the start. And then after this short introduction of the project itself, I go to the program. So we originally had 3 speakers. I already made one grey, Suzanne van Breugel from NLR. Unfortunately, she fell ill, so she will not be able to give her presentation as intended. But we do have 2 very good speakers still in line, Fanny Jigdit and Erika Ding, who will present research that they did over the past years in relation to air cleaning. And also in between, we will have some time for discussion and for also feedback from you or questions from you. So if you have any questions during this webinar, please put them in the chat, and we will try to look at them and come back to them throughout the webinar. And just to start off with the discussion or the option to have your feedback, we will also be using Mentimeter, just a few slides, so not that many, but it's a way to interact. What you can do in this case is take your smartphone, you can scan the QR code, or you can go to menti.com and use the code that is mentioned on the top of the screen, and then you will get to an interface where you can, in this case, provide an answer to this question in the slide. So I will wait a few minutes so that you can do this. And if you enter information on your smartphone, it will show. It should show, I hope, in this slide. So what are you looking forward to learning about today? That's the question. And of course, I would be very much interested to hear what you have in mind, and maybe our speakers can also reflect on that already during their presentations. So I'll give you a little bit time to answer the question. I see some of you already were able to enter. We got some. Okay, so we have some responses. So experience of others. I think that's certainly what we will hear today. Experience of different types of cleaners and how to assess them. Some practical advice. I think we also will be hearing certainly an update on the research, and the link to real world. I think that's covered as well. So I think several of these questions are of the hope that the learning points we will probably address today, and if not, please keep them in mind, and then we will keep them in mind, and then we'll try to look at that at a later stage. But maybe Fami and Erika, if you also have the answers or the things that are mentioned on the slide in mind, then you can maybe use that information also in your presentations to respond a bit. But I do feel that based on the responses thus far, that some of them hopefully can be answered to some extent, at least in our presentations today. So thank you very much for the input. You can still put answers in and we'll have a look at it later on as well. Okay, then I propose to move on to the next slide. And that will be our first speaker, Fahmi Gigit from University of Twente. It's mentioned here on the slide, but actually is also a senior level manager at the company Buster. And he has over 20 years of expertise in this company, business development, and also product innovation. He's a specialist in air quality and air cleaning technologies, and that covers domains related to infection prevention in healthcare, but also veterinary environments, food production, hygiene, and high care clean room designs. Well, you see University of Twente below his name now, because he's also currently pursuing a PhD at the University of Twente, where he focuses on the impact on the behavior, impact, and mitigation of airborne biological particles, and also with this academic activities. He also tries to deepen his professional expertise, which he already has a lot on air quality and air purification. He's also living quite close to the Dutch-German border, or working quite close to the Dutch-German border, and therefore he's also well known with the German activities in the field of air cleaning. He's also a member of several regulatory and advisory bodies, such as the DIN and VDI. And it's also that knowledge that he can bring into our MIST project, and which is, I think, very interesting and very important. And it's also some of the topics from this regulatory work and from his PhD work that he will be presenting today. And he entitled his presentation Ventilation Systems and Mobile Air Cleaners. So Corona showed us the false safety we were exposed to for decennia, which is quite a interesting title. So I'm looking forward to the presentation, Fahmi. Please, you can take over from here.
Yeah, thank you very much, Marcel. First of all, I'm honored to be asked for sharing our experience. And capital thanks to you and Atze and Elam for the organization of this webinar, of course. And I will share my presentation. As you discussed, I'm a guest PhD here at the University of Twente, and also, as said, a member of German VDI and DIN. And I noticed it's a little bit of a joke also. It's a German Gründlichkeit. During the Corona time, I got a letter at home with the mail, and I was ordered to take place in a special committee for Corona protocols. So then you know how seriously Germany took this issue, and I'm happy to share my knowledge today. I will share the presentation, clear for everyone. I think you can see it, and I'm clear to hear. Yeah, ventilation systems and mobile air cleaners. A very tough title. Corona showed us the false safety we were exposed to for decennia. There's a reason for it, because when we go to the first slide, you see a picture, and the picture says more than 1,000 words. If you look at the research around airborne viruses since 1941, it is relatively neglectable. Just when Corona started, also heavy research started. Although SARS-1, swine flu, made indoor air quality already a medical, a social, but also a very heavy economical issue. I mean, most of us remember 2012, 2013, when we had Hong Kong SARS-1, airports were closed, and later on the swine flu, bird flu. So, I mean, we didn't learn from that until Corona came. And why is that? I mean, the awareness of air hygiene, especially for viruses, yeah, is a recent development, because maybe the measuring the viruses in air is not that easy as bacteria. It is air, it's not visible. So a lot of reasons can be said, but the most important is, what I want to attend today, is that the pandemic showed us also that we had a false safety we were exposed to for decennia by thinking that ventilation systems or mobile air cleaners, yeah, are, let's say, a solution. Because case one, the false safety from mobile air cleaners. We have, at the moment, we have some standards to evaluate mobile air cleaners, like the clean air delivery rate, the CAT CRDR test. Yeah, but we researched that this protocol can make from a duck an eagle. Why? There's a reason for it. I will explain it. So that's why we discussed it in Germany, and we introduced in the DIN 6707 and the VDE 4300, we introduced a hygienic air delivery rate to prevent, yeah, false safety validations. And the HDR is a much more accurate measuring protocol. We will explain it in a few sheets. The proof one we provided. If we look at CFD simulations, you see on the left, you see a device with a capacity of 1200 cubic meters and a specific flow characteristic. And but you see also that the device does not cover the whole room. It's only recirculating the mass of air around itself. And during the CRDR test, in the middle, the B figures, there's an additional fan driving along the device. And what happens? It helps this device to, let's say, catch and fetch and bring the aerosols to contamination inside the classroom or the space to the device. So you have an additional help which is in practice not present, like figure A. So this protocol is not realistic. And on the right side, you have a device which is much lower fan capacity, but a much better flow characteristic. So the main message here is, one should focus on the flow characteristics, the fluid dynamics of a device, instead of the capacity of the ventilator or the unit itself alone. And how do we suggest it to test it? You put it in a room, you wait 30 minutes after you created a basis contamination level. You have a natural decay. You repeat the test again with active device, mobile cleaner, but without an additional fan like the CAT rate test. So the device itself should do everything. And the difference between those, the natural and active, can be, you can derive the hygienic air delivery rate from it. What did we do next to prove it in practice? We just took several professional and semi-professional devices. We took their own published papers, like you see on the right, a screenshot of the from the first device, which was published by Professor Kehler in Munich in Germany, the reduction dilution curve from the device A, which claimed to have 1200 cubic meters in a classroom of 200 cubic meters, which means an air change of 6. An air change of 6 means that it should dilute the contamination within 23 minutes. You see the green spot on 0.4. But it did in practice, it did it in 0.6. So this means that it behaves like a device of 760 cubic meters. And that's the hygienic air delivery rate, which is the netto volume. If you look on other devices, you get the same trend. And some devices which are household devices not even come near of having any effect in a room. But later, Erika will also show that the 99% claim of devices, is not always 99% in the practice. So this is the first proof that we should not focus on the capacity of the ventilator, but we should focus on the capacity of dilution inside a space. This paper has been published and peer-reviewed, and it's online available through this link. The next fall safety is for HVAC systems, building management. We know that air comes in the ceiling, and if you have a bad position of the exhaust grid, you have, of course, a big shortcut. If you have a better positioning in the second picture of the exhaust, it improves. And depending on the location differences between inlet and outlet, you can get a much better air exchange. This means the theoretical air exchange, which is always published based on the air inlet capacity, divided through the volume of the room, has nothing to do with the real exchange. So that's why we say here again, also for HVAC systems, we should introduce the hygienic air rate through the divided through the room volume as the real air exchange, because the theoretical it will create a false safety impression. Why? If you look at a test which we developed in the study I will present, and you look, you would theoretically have a space, you will fill it with CO2, and then you press the button of the HVAC system on, and you wait. How long will it take until it is, let's say, reduced 90%? If you look at the theoretical values on the table on the right, as said, you have 23 minutes you need to reduce 90% in an air change rate of 6. And if this not happens, if it happens in 46 minutes, that means you have a 50% of inefficiency in your HVAC system. And this test we did in practice 16 weeks during our research with Professor Detlef Loze, Professor Daniel Bon, and Antoine also. We both did the work in the office itself. We measured weekly the air volumes, the CO2 values, and we had 2 systems integrated in this building. One with the exhaust in the ceiling, and one with the exhaust in the near the floor. You see that here in this picture. So we could, every 2 weeks, we changed the modus of this office, which was occupied by 36 employees, a big open plan office. And what was the result? We saw that the air handling unit itself, we measured this literally 6,000 cubic meters, and there was a difference between the overhead mixing and the downflow mixing of around 60%. When we did the test with CO2, when we did the test with particles, 2.5 and 10, it was even bigger because they are heavy. They love to go in the direction of the floor. And even when we looked at the continuous 16 weeks of the CO2 levels were approximately 10% lower than the in difference of it to each other, but still not correlated to the 6,260 cubic meters. So is this unique? No. Other research programs also confirm this. Yeah, the Pedro Venti from presented last week also said, yeah, that you have to focus also on the fluid dynamics in a space, yeah, not only on the capacity of the installation. So this is good to confirm from several research programs. Yeah, the overall summary. Yeah, Corona has proven that there is an urgent need for new regulations preventing false safety. The existing regulations are too open. And unfortunately, we had a lot of cowboys who said, okay, I'm not forced to provide this data. I will only provide the data of my ventilator. And some of them even provided the data of the ventilator free blowing, not even integrated in combination with the filter. And the existing certifications, they are the reason why we have false safety. They are not rigid enough and they are not mature enough. So there's a lot of work to do here to research and publish more on these issues. Yeah, the major interpretation error, which we also discussed during the Pedro Venti and also inside the MIST program, is that you have individuals' measurements are always ideal. But if you combine them, they can influence each other negatively. So, and this is the reason why we propose to have post validations. When you have, for example, in HVAC systems, what is wrong to have next to the paper of the air handling supplier, where he measured literally the air flow of the inlet grids, to have also an hygienic air delivery rate test conducted. And so you have a post validation to see what is the real value. And then you also know, because, for example, in the restaurants or in the office, we claim 30 cubic meters fresh air per employee. But if these 30 cubic meters will not arrive to the employee, if only 20 arrive, yeah, then you don't meet the regulations. So the post validation protocols, yeah, should be 30 cubic meters and not the technical protocols. So that's my conclusion, that there's a lot of work to do. And from my point, of course, it's in a short webinar. If someone have questions during the meeting, welcome, and thank you for listening to this short 2 cases, which are published and available through the links. Thank you very much.
Thank you very much, Fami, for this nice presentation. Thank you for making 2 points really clear to us. So, question to the audience: are there any questions to Fami following his work and research and the results from that?
As a German say, it was so clear, although they don't dare.
No, but let's. I do have a question for you, Fami. So, you did HADR. I think is an interesting one. So, but I conclude that for air cleaners to look into actual performance, that you can only answer their performance in real life. So you always have to test them in real life to learn whether that is the only, what it actually delivers. And I was wondering how practical is this if you have many rooms or you want to sell a product. So how can you then understand or if you have the need to do measurement every time, is that really practical, and to what extent is it needed, or do you have some ideas about that?
A very good question. It's a main question we discussed during defining this regulation in Germany. And when we published it, it was said, okay, who can validate this? Of course, you have some universities who could have like you have a room in Eindhoven. Yeah, this room is let's say a mock-up of a classroom. Yeah, Philo has a mock-up of a classroom, and in these kind of settings, these kind of devices should be positioned based on the advice of the manufacturer. So our link is in this case because we noticed also, for example, these three devices D, E, F. Yeah, they had multiple positions in the room, and for every position in the room, there was a different hygienic air delivery rate value. That's normal because the fluid dynamics changes based on the position and based on the interior settings. I'm fully with you, but again, in this case, we asked from the manufacturer, this is our mock-up, and you tell us where to position your device, and then we will test it. But the biggest message here is let the device do the work and don't help it with additional mixing or homogenization ventilators. That's the message. And of course, I'm with you that it's in practice difficult, but like cars, you go to a validation center to have it TÜV or APK as you call it. Same here. So this is obligatory.
Marcel, have you seen that there's a question about turbulence effects?
Yeah, I see that there are two questions popping up in the chat. Thank you for that. So one of the questions was about measurement of turbulence effects. Maybe it's not sure how it relates, but maybe it's in general the question, did you look also, so you measured, I think mainly a contaminant, CO2 concentration or particles, but did you also look into the airflow itself, so the velocities, the vectors?
Yes, we have, for example, we did if you look, I had no time, of course. Now we have a little bit more time. I didn't put that sheet in it. There's also in the published paper, in this paper where this is where this is published. Yeah, we also have noted that the flow characteristics, how you can improve a device. So we have also advices how to improve it and use fluid dynamics as a tool to optimize a device design. Yeah, what most do wrong is that they make the air exhaust area bigger than the air return area. That means the air exhaust speed is lower than the return speed that you see also in this device. So that means you get more drag from the exhaust, so you get more circulation. And this device, for example, has a less pronounced effect. So its message is fluid dynamics design is very important. Yeah, when you design a device to improve the mixing in a room. Seeing the next seeing how clean rooms tend to use downforce to realize the desired condition, doesn't that mean that the resulting between overhead and downforce performance is to be expected? Yes, it is expected. And but how many offices do we have who have this in practice? I think 0.00. Or none. So that's a very good question. Why don't we use this kind of knowledge and experience? If you also already look from energy perspective, that you can save a lot of energy by doing this kind of design. That was our message in the paper also.
Okay. Yeah.
What role plays the location of the emission source for the?
Maybe a combination with that question. I think it's about the position indeed of the source. I also want to add to that question a question I still had is about what was the position of the measurements? Where did you take the measurements? Yeah. So and location of the source and the measurements of your contaminant.
Yeah, this is a trick of the hygienic air delivery rate in comparison with the clean air delivery rate. There, the test is exactly in the hygienic air delivery rate. You also have the ventilator, yeah, present, yeah, pre. So when you emit the aerosols, you put off on the ventilator to make an homogenic aerosol contamination in the room. Then you shut the ventilator off and you put on the device. Yeah. And at the end, before measuring again the post-contamination, you have also again the ventilator optional on to get a homogenic situation in the space. Or you use what we also described in the new regulation, 5, 6, 7 measuring points, and you take the average.
Okay.
So the main difference is the ventilator does not run during the device simultaneously.
Yeah. Okay. So you mix with a fan extra to ease the measuring part in the end.
Exactly.
Yeah. Okay. Well, I think we have to move on to the next presenter. I see a question popping up, but I would like to ask you maybe to ask Fahmi later on. So I would like to go to the next part, and I will share my screen again. If I can take over, yes. Sorry. I have 2 screens. Yeah, how it works. There he is. So, but before we move on to the next presenter, I have another 10 million question for you. And already somebody looked at it. So here the question is, if you have a lot of money to spend, what would you use it for? And when I was looking at the question, I think you can interpret it from a single building perspective, a research perspective, or a more group of buildings perspective. So what would you like to do if you had this amount of money available and could improve the indoor air quality with it? What would you spend the money on? And I see a nice response already. So looking at using mechanical ventilation with options to filter. So also more mandating and air quality standards, which I think is also an important one. So please feel free to give your idea about this question. Maybe it's a difficult one. Or you want to keep your 10 millions with yourself? That's also possible, of course. I didn't think about that one. But I think it's not one that's easily answered, apparently. So what I will do, I will just go on to the next presenter. And that's Dr. Erica Ding. Dr. Erica Ding is currently a postdoctoral researcher in the Department of Architectural Engineering and Technology at the Delft University of Technology. And she focuses on improving the indoor air quality, especially in educational environments, and then looks into ventilation and air cleaning strategies. So I think it's quite well aligned with what Fahmi is also looking into. She obtained a PhD recently at TU Delft, and also there she looked into several issues related to ventilation and air cleaning. They were part of several projects that were commissioned by, for example, the Ministry of Education, Culture and Science, but also other institutes, and also did a lot of work in that field. they were very much interdisciplinary and also, of course, very societal relevant during the COVID pandemic. And it's very interesting to hear today a bit more about that work. Dr. Ding has a multidisciplinary academic background and has also research experience that relates to thermal comfort, sleep quality, green building assessment. But again, today, her focus will be on air cleaners and the research that she did about that. And that was also part of a PhD. So healthy air for children, are mobile air cleaners the solution for classrooms? This is the question that she posed. Looking forward to hear the answer. Erica, the floor is yours.
Yes, thank you very much, Master, for the kind introduction. So first, let me share my screen. Yeah, I hope everyone can see it.
Yep.
Yeah, okay. So good afternoon, everyone. It's a real pleasure to be here with you today. And my name is Erica Ding, and I'm a postdoc researcher at TU Delft. So in this talk, I will share our work on the feasibility of mobile air cleaners in classrooms, looking at it mainly from a practical perspective. So before diving in, I want to acknowledge the people and the projects behind this research. So first of all, Professor Philomena Blausen, who has been my supervisor since my PhD. So everything has been done thanks to her support. We've also been collaborating closely with Professor Daniel Boon and Dr. Antoine Gaillard from University of Amsterdam. So in 2023 and 2024, we've carried out 2 research projects on mobile air cleaners in schools, both funded by the Dutch Ministry of Education, Culture and Science. So the first one was done through our collaboration with UvA, and the second one was with a broader consortium, including UMC Utrecht, Utrecht University, ICRADE, UvA, and TU Delft. So the first project was mainly about doing lab experiments on the mobile air cleaners, and the second one was like a follow-up field study to apply the mobile air cleaners in real school classrooms. And these 2 studies form the main story of today's talk. The COVID-19 has driven us to reconsider indoor air quality and occupants' health, especially with the increasing awareness of the airborne transmission of infectious pathogens. However, many studies, also including ours, have found that ventilation in classrooms is often insufficient, despite the mechanical systems used or keeping all the windows and doors open. So to address this, the ministry asked us to investigate whether mobile air cleaners, or in short, MACs, can be a supplementary solution targeting particles when ventilation falls short in classrooms, and if so, how they should best be used. We noticed that most previous studies tested only one type of MAC without explaining how it was chosen, but as a user, this is the first thing they need to do. That's why we started from screening over 300 products on the market. And after filtering by some basic information, we narrowed the list to 152. And for this, I summarized their air cleaning technologies and their induced airflow patterns, which means how dirty air is extracted in and how clean air is supplied. So we can see it's quite common for a device to combine several types of air cleaning technologies, but still HEPA filter is the majority when it comes to particle removal. And regarding airflow patterns, there are mainly 2 ways for clean air supply, either vertically upward or horizontally. And as for return air, it's usually taken in from the sides. So later, based on the device's technical specifications, the cost, and relevant standards and guidelines, we set up a series of criteria, and step by step, we ended with 8 devices, which was also the maximum number that we could test due to the budget. So here are the selected mobile air cleaners for testing, and you may wonder why there are only 7. Well, that's because the 8th one never got delivered to us, which was a pity. But among these 7 devices, we already have a good diversity in air cleaning technology, fan capacity, size, and press, etc. And since the goal was to achieve our target total clean air delivery rate, or we call it CADR, in a classroom environment, the number of devices needed was therefore determined based on the rated CADR per device. For example, Mach 5 has a powerful fan, so one device seems to be sufficient, whereas smaller devices like Mach 2 and Mach 3, they may require 4 units operating at the same time. Well, I think the idea is the same as Fahmi just mentioned in his presentation, that these CADRs are claimed by the manufacturers, which usually is tested in an ideal lab condition and can differ greatly from practice. So that's why we need to test them under our own setup. So those selected mobile air cleaners were then assessed in our lab via 2 different tests. The test facility, which we'll call the experience room, replicates a classroom setting. So we have tables, chairs, and we have a smart board in the front. And the first test was the decay test for PM2.5 and PM10 to determine the particle removal efficiency and the total CADR. The second test was the perceptual evaluation of noise and draft that caused by the devices, and is voted by a panel of subjects. In both tests, we included different fan settings for each device, and then based on the number of devices that's needed, we considered different ways of placement. And then based on the results of these 2 tests, we determined the optimal configuration for each Mac, which was then validated in a lecture room at TU Delft. And this figure summarizes the results of the optimal configuration for each mobile air cleaner. Well, the blue bars are CADR of the lab tests, the gray bars are the CADR of the validation test in the lecture room, the orange bars are some pressure levels measured, and the smile faces are the percentage of acceptability of noise voted by the subjects. Oh, apparently all of them vary a lot among these devices. So let me go through details according to these factors that are strongly related to the use of mobile air cleaners. First, air cleaning technology. The test mobile air cleaners used either HEPA or electrostatic filters for particle removal, which did not lead to big differences in their efficiency, so both were fine. Then the induced airflow patterns, which made a big difference. Here we found that the mobile air cleaners with an upward air supply, like either vertically up or a bit like angled, can better distribute clean air in the room than those with a horizontally air supply. And this explains why Mach 1 had a much lower CADR than the other Macs, because this is the only one that had a horizontal air supply. And different ways of placement did show slight differences, which then highlights the importance of maximum coverage of clean air across the occupied area. And I'll move on to number of devices. If we look at Mach 2 to Mach 6, the 2 that needs 4 devices, which are Mach 2 and Mach 3, had the highest CADR, followed by the 2 devices that requires 2 units, which were Mach 4 and Mach 6. And the one that with only 1 unit, which is Mach 5, had the lowest CADR in general. And such differences are even more obvious in the lecture room, which shows the importance of using multiple devices, especially for larger spaces. And regarding fan level settings and noise, previous studies have recommended a ventilation rate of 8 to 10 liters per second per person for good indoor air quality. So for a classroom with 30 students, that means approximately 1,000 cubic meter per hour. So if 1,000 cubic meter per hour, which is marked by the black dashed line, is the desired level of CADR, then most of the mobile air cleaners need to run at their maximum fan level to achieve this goal, or try to achieve. As you can see, for Mach 1, it's far below. So the consequence is that their noise level are far above the limit prescribed for classroom environments, which is 35 dBA, as marked by the orange line. So only Mach 7 could fulfill this requirement. And that's because its optimal configuration takes its lower fan setting. Actually, this is the only device that could achieve a decent balance between CADR and noise level. So lastly, user perception. From Mach 1 to Mach 6, even though the measured sound levels are all very high, the subject's perceptual responses were different. So they found some are more acceptable than the others. So based on all these results, we then selected 3 of the Machs to move on to the field study. Initially, we were thinking of choosing Mach 2, 6, and 7 because they're showing the best results, but unfortunately, the order of Mach 2 did not work out. So in the end, we selected Mach 4, 6, and 7. These are the some information on these Machs. So all of them requires 2 devices per room, and the fan levels are corresponding to the total CADR that are calculated. So for the field study, we selected 5 primary schools in Roermond in the Netherlands. On average, we selected 9 classrooms per school, and these classrooms were divided into 3 groups by Mach type. For each group, 1 classroom was selected to perform the IAQ, or indoor air quality monitoring. First, of course, we had to install the devices in the classrooms, and there we really encountered some practical challenges, such as limited space for extra appliances and limited sockets and other facilities. So for me personally, this was a lesson learned, because no matter how carefully we design and set up the lab tests to mimic real classrooms, the real world situation always turns out to be a different story. So the solution really needs to be flexible. And that's why we decided to simplify the configuration. So we tried our best to place the 2 devices on the opposite side of the room and let them face the occupied zone in the room. So from there, the field study lasted for 6 weeks. For school 1, 4, and 5, it began with 3 weeks of Machs turned on and followed by 3 weeks of Machs off. And for school 2 and 3, the order was reversed. So these violin plots show the daily average concentration of PM 2.5 and PM 10 in each classroom, which are made by Dr. Antoine. The green violins are when Machs are on, and red violins is when Machs were off. So it is obvious that the PM concentrations were much lower when the Machs were in use. And the difference was statistically significant for almost all classrooms. So when further grouping the classrooms into intervention and control periods, the results are even more clear. The mobile air cleaners significantly reduced the PM concentration in the classrooms, while CO2 and TVOC remained similar. And this again validated our findings of the effectiveness of the selected mobile air cleaners in the previous experimental tests. And as I mentioned in the beginning, this field study was joined by many institutes. So we also had researchers from UMC Utrecht and ICRADE carrying out studies focusing on user experience. Since related papers are still under review, so today I'm only sharing a few general observations. So they combined questionnaires and interviews with teachers, students, and school managers. And then from there, they explored experiences, satisfaction, and perceived feasibility of Machs during classroom use. So the teachers, they found Machs easy to operate, but they also reported noise, drafts, and space constraints as the main barriers, and their satisfaction decreased over time. And for students, they actually adapted to these new appliances really quickly, and in general, they had a neutral or positive attitudes towards them, and they rarely disturbed by the devices. Well, for school managers, they have this supportive attitude in principle, but also emphasized the need for clear evidence of health benefits. So I hope that in the near future, these papers will be published so we can discuss more details. And so now it's time to wrap up some conclusions and practical implications. I think Both the laboratory and field studies confirmed that the selected mobile air cleaners are effective in removing particles in classroom environments. And it's really important that the selection and configuration should be tailored to the characteristics of each space. For classrooms, first, airflow pattern matters. Upward air supply provides better distribution of clean air. And second, proper placement is crucial to maximize coverage of the occupied zone, and multiple units are often beneficial, especially for larger spaces. And user perception strongly influences visibility. While people's response vary, noise and drafts remain notable challenges in practical use, and that requires further optimized design. So future work should focus on long-term evaluation, addressing factors such as performance degradation, seasonal variation, user adaptation, maintenance, and energy use, etc. So let's go back to the question I posed in the title of the presentation. Are mobile air cleaners the solution for classrooms? Well, they're not the only one or the ultimate one, but they can certainly be part of it if we combine technical efficiency with comfort, awareness, and good design. So here is a list of some related publications that are supporting the talk today. And that's all for my presentation. So everything here is also part of my PhD research. So if you're interested in learning the whole story, then you can scan the QR code and read my thesis. Thank you again for your attention.
Thank you very much, Erica, for a very nice presentation, which I think will have some questions raised. So I don't see them. I see one from Ats in the chat. So please feel free to also put your question there, and I will try to phrase them to Erica. So the question that Ats posed is about the efficiency of ceiling-mounted air cleaners versus mobile air cleaners. Do you have research into that or an opinion on that?
I haven't really researched into the ceiling-mounted air cleaners, but I think the idea of using mobile air cleaners here is first because they're flexible. So because in a classroom, we really need some devices that can be placed freely at different places. I think regarding efficiency, that we really need to do more tests. Because
it was not part of your work, so it's a difficult one to answer, I think. But I think it's a very also a valid question, because it's like an alternative solutions that you can think of. We have another question from Lily. It's on slide 7. I don't recall the slide exactly, but you measured in the lab and in the classroom, and indeed you saw some differences between the two. I think the lab was lower than the classroom. So do you have any explanation for that outcome?
Yeah, so actually there's a difference, because in the lecture room, because it's a university lecture room, so it has this mechanical ventilation going on, and then we could not turn it off. So that kind of added to the CADR of the mobile air cleaners. So that is why it's slightly higher. But also from there, because I didn't mention that in my presentation, but that also shows the potential of combining the mechanical ventilation systems together with mobile air cleaners and together to improve the indoor air quality in the classrooms.
Maybe to link it to the previous presentation from Fahmi. So you measured the CADR without fans, without mixing the room, or did you do some mixing and the measurements according to the HADR or version?
So you mean during the decay phase, or
exactly.
No. So in the lab, because we have control over the ventilation system, so we can shut it down during the entire experiment. So either during build up or during decay, the ventilation was shut down. But in the lecture room, we couldn't do that. So we always had this background ventilation going on when we do the test with the mobile air cleaners.
We have another question also from Lee. It's on the on-site measurements. So schools themselves. So apart from the difficulties that you were confronted with, of course, you also have to deal with the environmental changes, the weather, and so on. So how did you include that, or in the experiments, and how do you think it might have affected the results?
Well, that's a really good question, because that field study actually was like a pilot study. So we did that to see whether we can move on to do a bigger field study. So there we really just was like thinking, we really just wanted to look at whether the mobile air cleaners that we selected can work or not in the practical scenarios, or like in real school classrooms. So we just put them there and we let the teachers use them, and then we didn't say give other instructions, users behavior, say if they should open or close the windows or not, or if they can, like we only let them know like when they should turn on and turn off the devices, and other than that they can do anything they want. So there's no other control over other factors. So the outcome is like it's a general results that then the mobile cleaners, they are effective, but then other than that, it's like if we want to really know how, like what are they removing, and then what's the exact efficiency, then that requires more, say, rigorous study design. Yeah.
Okay. So there's another question, but I think that comes back again to the issue of ceiling mounted air cleaners and the efficiency and potential of that. I think it's something, if I summarize your earlier response, is, well, you didn't research it, so it's also difficult to answer, I think. So that's, I think, at this point, it's certainly an interesting topic to look into, and maybe to look also at the research, which apparently is already there about this topic. If there are no other questions, I do have one question indeed on the sound pressure level. So you experienced that it was quite acceptable still to have 45 dBA in the classroom with these systems. So it was not that complicated, because it seems quite loud, but it's always an issue with these systems, or appears to be an issue with these systems if you want to run them at high capacity.
Yeah, so you mean like at least 2 of the devices that we chose and we put them in the classrooms, they had like a measured sound pressure level of 45 decibels. And
yeah, so did you see differences in the acceptance of the 2 with 45 decibels and the one with only 34? Did you, or wasn't there any annoyance from the sound level, sound pressure levels?
So you mean for the experiment that we did in our lab, or you mean with the
in the classrooms? In on-site studies in the schools.
Oh yeah, well, because those are like still on the review, and then it's like done by the other research team. Okay. So yeah, I don't have the like detailed information here today. Yeah.
Okay.
Hopefully in the near future.
Then we'll hopefully read soon more about it. Any last questions to Erica? If not, I look at the time. We do have one overall question, but maybe based on what I've seen, I did prepare a few slides of some of the work that we are doing within the CLARE project to fill in the gap from Susanne. It's just a few slides, but to let you know, to inform you, the audience, of what is done there, or is being done there, and it's work done here at Eindhoven University, but together with many others, and especially also Utrecht University. So I will share my screen. I don't have a nice starting page, but it's the CLARE project is a Health Holland project, stands for Clean Air for Everyone, with a focus on the application of air cleaning devices, portable air cleaners, in classroom environments. So it's a bit similar to what Erica was just telling you about. So what we do within the project, we have different work packages. I will focus now mostly on the work package 3 and 5 work packages. where we look into the performance of these types of air cleaners, portable air cleaners, mobile air cleaners. And also I give you one slide about the intervention study that is done or was done. So for the lab studies, our question was looking into the research gap of the CADR, which is assessed according to standards and how that relates to the practical situation. So that really aligns with also what Fahmi has been explaining with regard to the HADR, so the healthy air delivery rate. And we wanted to evaluate how the CADR, if you put them in the practical application, how much that differs from the theoretical determination. So how robust is the test that we have? And this work has been done in our lab, not by me, but by Lily Xia. She's also on the in the webinar. And so we have set up a test where we do test according to the NC-AHAM CADR test, where we put the air cleaner in a smaller room, 28.5 cubic meters, and perform similar decay test for natural decay and also with the system on. And from that we can derive the CADR, so you can calculate that. That's the standard test room. But of course, this is not reality. So we also want to put these systems in actual rooms, so larger rooms, most probably classrooms in our case. So therefore, we built here in Eindhoven a larger test room, 10 by 7 by 3, so relatively large classroom, but still a large room, where we also do tests on the performance of these systems in a similar way as is prescribed by the CADR, so with fans that mix the air very well, but also a bit more in line with what Fahmi was telling, according to the HADR, so without the fans actually running while the system is working.
Marcel, sorry to interrupt, but we don't see your presentation.
Oh, I forgot to share. Sorry, you had to warn me earlier. Really sorry for that. Oh. My apologies. So now you should see it. Yeah. So well, the first slides you've heard about. This is the room I was telling you about. So from the NC-AHAM that we prepared in our lab, where measurements have been done according to the standard. But again, we have also want to know what's the performance in larger rooms. So we've built a large room, classroom size, where we also do tests in a similar way as is described by the standard, with fans mixing according as to what Fahmi was saying, not really realistic. So the next step also is looking into this performance when you don't have these fans mixing and only the air cleaner functioning. And we also looked into different types of air cleaners, different ways of bringing air into the room and taking air from the room to the cleaner, to also understand how that is affecting the performance for these different cases. So we have several stages where we have been measuring, so the measurements are almost finished. Looking into the standard case with the small room, the larger room, and then we also combine it with the positioning of the air cleaner. So if you put them in the center, it's a different case than when you put them in the corner or near the wall. And in the last stage, we also are combining it with mechanical ventilation and see how the performance then is. So it's quite a suite of measurements that we have been doing and gathering information for. And that's, well, gives us a much better idea how the CADR, the theoretical one from the standard, actually relates to what a more realistic case is. And the really final step that we just finished measurements on is putting in actually a classroom environment with lots of heat sources. So actually pupils in the room, creating also an airflow and also repeating those measurements. Well, here you see just one example of some of the results. I really will not show you more. Also, we are in the process of writing articles about this work. So hopefully soon you will, you can read more about it in more detail, but you see here the effect of differences between the small room and the large room, and the fact of putting fans on during the measurements or having them off, And you see indeed that there are some differences, though, yeah, it's in the order of 10%. So maybe in this case, not very much. But if you also look at the measurements that we do throughout the room, so we have many measurement devices throughout the room, we also can see gradients in the room and also learn about how the variation in the room is. Last slide, also looking at the time, is the intervention study that we are that we have run. So it finished already at the moment. So we looked into comparison of the effect of air cleaners or not in a lot of schools, more than 100 classrooms, where we either had a control room or we put systems with HEPA type of air cleaning or with other types of air cleaning. And then we measured in all these classrooms the typical physical parameters, CO2, but mainly PM, very important, but also biomarkers, so biomarkers in this case, which was done by University of Utrecht by Esme Janssen, who is also online, I saw. So these measurements were run for a period over 2 years, not the whole year, but in the winter periods. And well, the results, the measurements have been performed, and well, the results are being gathered still, and analysis is ongoing, and we hope to finish also this part of the work early next year to finalize this project. So that is a quick summary of some of the activities which are also ongoing, which seem to be very much in line with the activities that have run in parallel already by Fami and by Erika. Not sure if any questions are related to that. We do have some time, and then if not, then I will go back to our last question, and I have to share again. Sorry that I forgot to do that. So there is some general discussion that's still possible, and also here I have a Mentimeter prepared with 3 well, sayings and a question to you to rate the importance that you put to these topics. So if you agree or disagree with the statements. And I hope you can access again the Mentimeter. I see you do, so that's great. Thank you. Okay, so there's quite some agreement on the statements. Maybe not that surprising because you're here with us in the webinar and are interested in the topic. So I can imagine that you are well, seeing the potential of air cleaning. Of course, there are always issues that you can discuss. I see one remark from Kieran in the chat about the issue F. We're looking very much at classrooms and schools, but well, you know that that there is well, a lot of time that we are not in the classroom in the school. So how do we need to look into that or take that into account? I think is a very interesting point. Maybe Kieran, you have some ideas about that, or just want to raise the point. You can, I think you can talk if you would like to say a bit more about it.
You know, just raising the point because it came up in some work that we did before.
Mm-hmm. And do you think there's a need to well, if we are looking into this air cleaning, that we should cover all and not stay with just a few rooms where we think it's important. What is your opinion about that?
To make a very obvious and stupid statement, but for deliberately, kind of air is everywhere, so it's very, very difficult to in my view to bring that down to areas that can be in terms of the epidemiological issue, to bring that down to areas that can be satisfactorily isolated. It's a real challenge. I think it's a challenge for the whole industry.
Yeah,
because the situation is so dynamic, and the in vitro testing that's going on, I think it's very good, and it's extremely being well thought out. But as far as I can see, it often doesn't happen with people in the room. You put people into the room, you introduce, many different variables. It's very, very difficult. I know that's not a very helpful thing to say, but I think that's the issue.
But it's good, I think, to be aware indeed of the complexity that we are dealing with. And indeed, I think it's small steps that we can make, but always we have to know what we do not know.
Yeah, and it has to be very. I think it has to be very sector specific. Yeah. So a healthcare situation is different because it's possibly more amenable, because then very often you have people who are there 24 hours a day in terms of patients and staff who are there, for very long periods of time. Just a thought.
Yeah, thank you for that remark.
But excellent papers today. Congratulations to everybody.
Thank you very much. So we have Lucy raising her hand. Lucy, please.
Yeah, thank you, Marcel, for a very nice webinar with interesting talks. I find all this research very interesting and relevant, but for me it would be so helpful if also epidemiological parameters would be researched. For example, if in classrooms with air cleaners and without cleaners, if you would also record the numbers of infections occurring among the children, and see if that's indeed lowered, or if not, it could also turn out that children are just infecting each other via other routes and snot and direct contact and whatnot. And so even though I don't doubt that air cleaners are very effective in removing particles when they are set up in the right configuration, this is for the public health community, it's just not convincing enough proof that it's actually lowering the amount of infections. And that's, I think, the kind of research that's needed, and we shouldn't stop at just looking at particles. That's my main comment.
I think it's a very, very valid point. Maybe Esme, you can. No, I'm not sure if you're still online, but within the CLARE project, there is also during the test that we did, there was also the question to the schools to monitor sick leave. So there's information there, but it's a very difficult part, of course, to do this in a good way, and I think you can agree with that, Lucy, that it's not that easy. It's a very valid question, but again, maybe in line with Kieran. So the complexity is really large to ensure that you cover the right aspects, because indeed the classroom is good, but they are not 24 hours in the classroom. So also there you need to. We have some examples in the past where also this went wrong to really qualify outcomes. But I think it's a valid one which we should look into, and indeed exposure is not the same as infection, so it's a different one. Sorry, I think Kieran, you wanted to add something?
Yeah, just very quickly, we had a small study with Daniel Bond towards the tail end of COVID in a school, and just to my previous point, we got a statistically significant improvement in the number of infections in the early part of the wave, but then as the wave became more general and more intense, that effect got lost in the noise of the overall statistical effect of infections. Just the wave became too big to distinguish any significant effects beyond the first 2-3 weeks.
Yeah. Okay.
So as always, the research indicates that more research is necessary.
Yeah, exactly. That's what we know. Yeah. So Esme, maybe you can add.
Yeah, I just wanted to say, we do look at within a CLARE project at absentees, but it's always like practical constraints because you can't monitor if they're actually sick or if their leg is broken or they go to the dentist, for example. So it's quite hard to measure due to privacy constraints. And I know another part of the CLARE project, they try to model like the translation from like bioaerosol spread to infection risk. But that's also very, very difficult because the model always makes a lot of assumptions, I know. So there's a lot we don't know yet, for example, about aerosol dynamics. But yeah, that raises difficulties in modeling. So I think that's one point that's still very difficult to actually translate it into epidemiological markers. So it's a very good point, but just a very very difficult one, I think.
Yeah.
Which is why healthcare is possibly a good sector, because they track infections religiously because they have to.
Yeah.
And we're shortly starting a study in a large hospital in the UK where they've got historical data going back 10, 12, 15 years. So hopefully that will.
So maybe we can learn from that how to do that best. I think looking at the time, maybe there are some one or two last urgent remarks that you would like to make. I see in the chat, Atze already put in some links to the CLARE project and the Petriventi project, if you are interested, so you can have a look there. There was also a question about sharing of the slides. I must admit, I don't know what was agreed upon, but I do think that because also several parts are published, probably looking at the papers, you will get more details than the slides themselves, but I assume it will be possible to share some of the slides and maybe in a shortened way as a PDF. But I will leave that to Atze and Elham to take care of. If there are no other remarks, then I would like to thank you, the audience, for attending this webinar. But of course, I really would like to thank our presenters today, Erica Ding and Fahmi Gigit, for the presentations that they gave. I think they were very nice, very inspiring, and also some good insights into the actual status of these air cleaners. And there's still a lot that we can learn and need to learn for its full implementation or full exploitation of the potential that an air cleaner might have. Thanks again for your presence. Also thank Atze and Elham for the organization. I hope to see you in the next MIST webinar, of which you will be informed about in due course by Elham, I assume. And for now, I wish you a nice afternoon and see you back next time. Okay,
Thank you.
bye-bye.
Thank you very much. Bye-bye.